Hello everybody and welcome to part 1 of our bash scripting weeks. We're going to be doing 2 weeks of scripting, and this video in the lab we do this week we'll talk about sort of basic scripting approaches, and we will talk about more advanced scripting approaches next week. So again, that's 2 weeks we'll be doing bash scripting, and let's just jump right in. So I have a kit for you. You can copy some code. It's available at this path. Don't forget the target directory in your cp command, cp/r, and there will probably be errors given that permissions errors that it couldn't copy a particular directory. I have my notes directory in there. I don't believe it's set to be visible to you guys. So after you do the copy, don't forget to do an ls. To make sure that some of the errors that you saw. See, that's the thing. Sometimes you'll see an error and it's not. It doesn't mean the entire copy command failed. It just means that part of the copy command failed, and so you'll probably see that. But don't forget to do an ls in whatever directory you decide to copy this into afterwards to make sure you have some files. Okay, so this week we'll be doing our readings in the D2L module, shell scripting. There are some topics in chapter 8 that we want to look at called on the bash shell. These are some of the more nuanced elements of how the shell interacts with the commands, the command line, and the processes. So take a read through chapter 8 if you haven't finished it already. Also, chapter 10 is exclusively about programming the bash shell, and so that is also on the slate for reading this week. Go through it, take a look. It's rather interesting reading, and yeah, so off we go. So here's what we're about. I'm going to cover some scripting basics and the idea of a script, how you write a script. We're also going to take a look at positional parameters, which is a way we can make our commands, our scripts, act more like commands that we know. We also have command line arguments to do that, towards that goal. In addition, we have some topics that I want to talk about that are just general programming topics. So if you haven't seen programming before, if this is the first exposure you've had to writing a script, these topics are good for you. If you are more experienced with scripting languages, you can kind of just like look through these to see the syntax, and especially the syntax diagrams I'll be putting up. So we'll look at control structures, we'll look at what a for loop looks like, we'll look at using variables in a script, and we'll look at positional parameters again, and then we'll take a look at a selection structure called the if-then, and normally this is set up for a collaboration session, but we'll be doing that on Wednesday night, so I won't be covering that now. Okay, so the first thing to know about scripting is that you already know a lot about scripting. Any of the commands that you know can be used in a script. We've already been using commands and learning about commands, and also processes in what we've looked at so far. So this is just a build on to everything that we've learned. I liken it to having a dialogue with somebody versus writing a letter to somebody. You've been having a dialogue with the shell up till now. Now we're going to learn how to compose our thoughts a little more in files. And the next thing to learn about scripting is that basically what you're doing is you're putting commands into a file. So any command you type interactively in bash can be saved in a file, and then when you type the name of that file, the commands that it contains will be executed. So let's take a look here. Okay, so if I use the ps command, I can see the list of my processes. If I add the user parameter, I see not only processes owned by my terminal, but I also see processes which don't have a terminal controlling them, which are, all of these are my processes. So if I wanted to put these in a file, as I've already done, if you look in the scripting directory, which is my working directory right now, add a file named cmd, you'll see that this is exactly what I had typed in the interactive sense. The first line here is a little different. The first two characters are the hashtag and the exclamation point. That's pronounced shebang, I guess sh for the hashtag and bang for the exclamation point. And then the path is the indication of where to find the interpreter for the data in this file. The shell uses this. It could be awk, it could be Python, it could be any number of the available interpreters here. This happens to be bash because we are writing a bash script. Any other command in the file, any line in the file which starts with a hashtag is just a comment. So if there's a exclamation point in the second character here, it's not particularly special, it's just a comment. So only the first line is important with this particular syntax. So how do we run this? Let's take a look at how we run a script. First thing to note, if I look at the permissions mask on the file, I have to have execute permissions. So set execute permissions on the scripts that you write, and then to run them, type the name of the file. Now, if you have added the local working directory to your path environment variable, this will work. If you haven't, you may have to indicate that you want to start the command in the local working directory. Either way will get you there. So there we go. There is the output that I had in the interactive case, and it was run in a script. So that's the basics of creating and running a script. A couple other things to know. So, as I mentioned, it's explained here on the slide a little better. The first line is called the script processor identifier, and here's the syntax details I just covered. When you name your scripts, you can pretty much name them anything you want to. There are a few conventions, which I cover here on this slide. Lots of languages use CPP, particular languages, lots of languages use the convention of using extensions to identify programs written in that language. So cpp.c.py for Python. Some people like to name their scripts with the .sh extension. Sometimes I'm one of those people. I just like the recognizability of it. The argument can be made to leave it off, though. If you are writing something that's going to act like a command, you don't have commands with extensions, so it is kind of silly, goes the argument. So, if I'm writing something that's like maybe a filter, I might not use the extensions, but you'll develop your preference over time, and as you get your own style, and you figure out which situations work best if you want to use both of them, or just pick one and stick with it. Okay, so another aspect of running your scripts. Remember how a while ago we had a few items that asked us to add a current directory to our path. So the way you run your script depends on, or can depend on, whether or not your current directory has been added to your path. So if you recall, in a previous module we had some questions that asked how to do that, and this is how you do that. At the prompt, you type the name of the variable and the equal sign, and then you construct on the fly a brand new value for that variable using the old value of the variable, and then concatenating the current directory shortcut, which, as we know from the file system, is the dot character. So we're just basically adding one more element to this list, which is an environment variable. And then if I want to make this change effective for everybody, every process, spawned process, in order to make this variable visible, or this change to path visible, I'm going to need to export it. So there's the syntax for that. So there you go. Now the difference is, if I haven't done the adding of the current directory to my environment variable path, I'm going to have to preface the running of my script with the current directory shortcut, so that when I run my script, the shell knows to start its search in the current directory because it's not going to find it in the path. Remember, the path is traversed. Each element is looked at as a potential place where the command may live, and it will run the first one it finds. So if I don't have it, if I do have it in my path, then I can just type it without referencing the current directory, and everything's fine. So make sure you understand that. Take a look at your path variable. Answer the question for yourself: does my path variable have the current directory in it? No. Well, here's how I can add it. And there's also a hint here that you can edit your bash rec file, and you can add this to the end. This type of edit, and then if you want to export this type, if you add those kinds of commands to the end of that bash rec file, when you log in, this will be run, and it will be a virtually permanent change. So if we want to participate in the environment and make our command act like and participate like other commands, one thing we want to learn how to do is to use the positional parameters and basically support command line arguments. So you can look at, I have two command examples here. You can look at the white space separated values in each of these examples a little differently. In the first, we are using the quoting aspect of bash to basically have three fields on our command line. We have the first being the command itself, the second field being the first parameter to that command, and then the third being a parameter. This is a file, in quotes, which is going to be interpreted in this case by ls as one file name, which is just incidental. So if I didn't have the quotes, we see from our playing with bash and reading about bash that it's going to basically make this into 6 fields. So if ls is still the very first and the -l is the second field, this is the third, the fourth, the fifth, and the sixth, okay, because this is not quoted. So you can get within your script, if you're writing your script, you have access to positional parameters, and you have access to each of these fields in the command line, the environment where your script is being executed. So you have these variables, and they are numeric, and you can use them. These should look familiar to you by now, because these may look like the awk variables. In bash, you have positional parameters. Any command that is passed into your script can be a parameter passed into your script can be accessed using these. The first field on the command line is 0, so 0 is going to contain ls in both cases here, and then any other fields are going to be accessed numerically. So the second field will be stored in field 1, so you can use $1 inside your script to read the value that is passed as the second parameter to your, or the first parameter to your command, the second field on the line. And then the third you can access from 2, which in this case is going to be one of two values. Either this is a file as a string, or this is the value contents of $2. So there you go. That's let's take a look at that next. How you might do that. Right. So that's all very well and good, but what does it look like? So if we take a look at this is in the script directory. If we take a look at the file that is in that directory called command line args, we will see a evolution of the previous CMD file. And what's different? Well, the L parameter is still there, the U parameter is still there, but now I've got, instead of the argument to the U parameter, which was the hard-coded string, which was my username, now there's this funny looking thing. There's a $, and there's a number 1. Now the $, just to review variable usage, the number 1 in this case is a variable. And the dollar sign, you typically see these associated with variables, and sometimes you don't, and that can be confusing. But if you think of the variable as a box and the name of the variable as a label on the box, and the dollar sign basically being some kind of implicit operation that says, hey, dump what's in the box with the label number 1, and instead of the label, display the contents of the box. Don't display the dollar sign, don't display the number 1, display the contents of that memory. Okay, so that's an expansion that happens when I use the dollar sign and a variable that's named. So that's what's happening. Now, the variable I happened to pick was from the previous walkthrough, was the number 1 field, not the 0th field, but the firsteth field, or the second parameter on the line, if you want to look at it that way, the second field on the line. So I can get a handle on that with the variable name 1. And so let's take a look at what that looks like when we run it. Oh, I need an argument. Okay, so I have something interesting here. The interestingness is being thrown by the PS command. It's not interestingness I introduced. A good script would. A good script, and we'll see how to do this, will interpret the number of parameters before it does anything else. And so that's what the PS command does. And as I want to emulate that, I'm going to try to build that into my script, but not at the moment. What I want to do here is rerun this command with the required parameters that at this point I don't really have a clue what it was supposed to be if I was trying to read it off of that last screen. But I just happen to know because I wrote the script using white box testing techniques. I can surmise that should be my username. Okay, so there it is. Now, what happened? I passed my username string as field 1 on the command line. So there it is. It trapped that value being passed in and handed it to the PS command. Command line args passed in this field on this variable, and I had access to that in my shell command using the $1, which then expanded to be the contents of that variable and then was handed to PS-LU with the expanded value, which was that string that was passed in on that field. Okay, you guys get the idea? Good. Hope so. So in addition to the numbered positional parameters you have available within your script for getting the command line arguments, you also have some special parameters that are available. So if you want to see the number of arguments that were passed without having to resort to counting them, you can use the hashtag variable name. That's just a special variable name. If I echo $hashtag, I'd see the number of arguments that were passed in when I called my script. Also, if I want to see all of the positional parameters, I have access to a variable called @. I also have access to the current process identifier, the PID. I demoed this in the process module. We have access to that. So there's another one that I would like to introduce. So, continuing our discussion of variables, environment variables, built-in variables that are useful in scripting, I did want to kind of touch on the question mark. So, this is going to give you the exit code of the last run operation. So, if I run it now, I get back 0. Now, just to refresh that, exit codes of 0 in the Unix world, 0 typically is a good thing. It's like saying it's nothing. Don't worry about it. It's nothing. Now, if there was a number there, now that would be something. But this is nothing. Don't worry about it. So, how do you interpret a non-zero return value? I mean, this is basically when you write a script and you use like the exit keyword and you use it in conjunction with a parameter that is the number. That number can be passed back. So and that would show up here as the exit status. So it's kind of implementation specific what they mean. So and your mileage may vary. You may find some standardization. I would think you would find a lot of standardization in like the system API elements. Now, but I think vendors may have different approaches. Different developers may have different approaches. Different open source projects may have different. So you get the idea. Non-zero bad, zero good. Now this is an exit parameter from I don't know what, probably the previous echo statement, but. Let's do something like this. We will ping our web server, which is nowhere near our Unix server. So we'll just let it run, and then I'll trap it and send it a Control-Z and interrupt. And so it stops. Now it returns me to the bash prompt. Now let me use my history key here and take a look at the dump of the question mark variable. Now it's 0. Okay, well that would be what we would expect. It looks like the ping command returned to 0. Even though I interrupted it, isn't that interesting? It had an exit status of 0. Clearly it was able to connect. So I challenged you guys a couple times in the last week to think about how you might use the network tools to basically automate determining whether a host is up or a host is down. So this might be a good way to approach that problem. So let's modify our host name. Something that is going to fail DNS lookup, I'm sure. Let's go ping www pcc ed who, and then we'll immediately unknown host. Can't get there from here. That's not a routable IP from here. Sorry, don't know who you're talking about. Go fish. So let's take a look at the exit status that ping returned in this case. Hey, it's non-zero. We should make something out of this. Well, what could we make out of this? We could make a script. I know we could make a script. Let's do that. Let's do that right now. Okay, Easter egg time. It is possible to do this challenge without using an if statement. We're going to look at the if statement next. I just wanted to put sort of an Easter egg up here. If you recall an Easter egg for this video. If you recall, we had discussion in some of the earlier chapters about using the list separators and the control operators like the semicolon, the pipe, the double ampersand, the double pipe for and or. The point I'm trying to make is you can use non-script ways to accomplish things in the shell, okay? And being able to complement both the shell techniques and the scripted language techniques, it's very useful. It enhances the script a lot. So take a look at this. I'm just going to hit my up arrow key and present a, believe it or not, this is all one statement. I'm going to leave it to you to parse it. I'll give you a couple of hints. This actually solves the problem of provide code that will determine whether a host is up or down. If I have a host that is up, see, you'd know I'd have to go to the very beginning of this buffer. If I have a host that is up, it's going to... Sorry guys, this is kind of moving slow. First thing to notice is we have the first group we made, I made using parentheses, right? So inside that group there is a ping statement, And also there is a redirect, right? So this is all one statement. And then we have this double ampersand control operator that is going to, if the preceding statement returns true, it will then execute the next statement. However, if it isn't true, that is, if this does not return true, then this won't be executed. So it will return a non-zero for the entire group, because both of these sides of this ampersand are not going to be true, so it cannot return a true value. So it is a non-zero value, and then that is picked up in the outer expression that I've made here. I'm using this control operator of OR. So if this returns false, this is going to be evaluated. So I'll let you read that. It's basically a very terse message given in this script or this command if the host is up, and a very, very confusing, long, hard to read, but hopefully explanatory and interesting message if the web host is not up. So here you go. I'll let you copy what you feel like copying and take a look at that. Let's see here. What's next? The most basic selection control structure available to you to interrupt and redirect the control of flow of your program is the if-then statement. So typically, here's a flowchart that basically shows you how this works. There is a component to your if-then statement called a test command, and that is going to evaluate to one of two things, true or false. If it evaluates to true, then the commands in the command block are going to be executed. If, however, this test does not return true but returns false instead, the entire block of commands will be skipped. So in the code over here, we have some syntax. The if statement starts with the if, and then the test command. The actual word test, this is the most basic expanded form of the if statement, uses the word test. Test is itself a keyword. This is how we're going to get that true-false value out. And then the command that you are asking test to evaluate, and if it returns true, then, and this then is part of the syntax, the commands that are inside the then block, which is delineated by the then and this funny looking word here, phi. What is phi? Well, the guys that did this had a sense of humor, and conveniently they wanted to end the block, so they just used if spelled backwards, and so that's phi. So this is the general syntax, and this is the effect on flow of your program, of the if-then statement. So here are some examples of that. If I use the test expression in its first form, where I'm actually explicitly using the word test, there's a lot of operators I can use, and these are detailed when you look at the textbook on the page 1005. The D2L shell scripting page lists a few of these. But you can evaluate expressions to test whether a particular variable is equal to a particular value using these funny operator notations here that they have. So this is basically the equality test. It's going to look at my positional parameter, which is, as I just indicated, going to indicate the number of parameters passed into my script, and if it is equal to 0, this entire test is going to return true, and if it's not equal to 0, it's going to return false. And the way that we're introducing this is we can use this to check whether or not we have arguments, and that is because the positional parameter, that's what it tells us. The pound sign or the hashtag positional parameter is going to tell us that. Although it's not a positional parameter, it's a built-in variable. So also there are similar things for checking whether or not a file exists. So if this file exists in the current directory, I'm going to use the f parameter to the test, and it's going to take a path to the file, and it's going to return true or false the entire statement if in fact this file exists. So there's a ton of these. Take a look at them. It's part of the if statement, and you'll need to use a lot of these. Depending on you'll use different parameters depending on what you want to do, of course. Another way to use the test command is to use this form of the command, which leaves off the test word entirely and replaces it with brackets. So you can use this in your if statement and basically put your test command in, to brackets, and you can get away with not using the test command. Some people have pointed out that you can get away with not using brackets at all. That's fine. If you can do that and it does what you need, then great. So you can have a look at a couple of these examples. I can do the same check here as we did in the previous form using the brackets. I can check for a file existing. The operator is the same, and the comparison of two values as the expression in this case is the same. The word test isn't there, it just doesn't have any, it just has brackets instead. Also, the f parameter still returns true or false if this file exists. There are a few more here that you can take a look at, specifically for files. If the file name exists and it's readable, I can check that with the R parameter. W is going to, W is going to tell me if it exists and it's writable. S is going to tell me if it exists and has a non-zero length. F is going to tell me if it exists and is not a directory. D is going to tell me if it exists and it is a directory. So just more things for your toolkit there. So in cases where we need to repeat things over and over again, we have the for loop. We have actually a number of loops. Direct your attention to the flowchart on the right-hand side of the screen here. We have a test again, so we have a for loop, and in our example here we have a variable called the loop index, which is going to iterate one by one through, in this case, a very explicitly spelled out list. This isn't usually the case, but for demo work it looks okay. I'm going to probably step through this here the code first because it's a little more straightforward. So we have a list of values, and I have a variable name here. Our script starts with a bin bash reference, and it's also just a comment that says what the name of the file is. So I have a variable here. So each time it goes through, it's going to start with apples. Apples is going to be assigned to the variable fruit, and then the contents between do and done, those commands will be run. And when they're run, the variable fruit will contain whatever the current value of the list is. So this is one form of the for loop that you can expect to see. And this is basically how it will work. So it will basically walk through each of these, and in this case it will echo the variable. Remember that we're dealing with variables, so if you want to dump the contents of the variable either for output to the screen or some other purpose, you can precede it with a $sign and then the name of the variable, and in this case this will just output the entire variable's contents, not the word fruit. So what might this look like when we run it? Well, it might look like this. Let's take a look at this script here in the kit called Fruit Loop. And this is exactly what was on the preceding slide. So let's just kind of review what this is doing. It is a script. I have a index variable present in my for loop, and then I have my list of explicit variable values, which each one of these will go in turn into the index variable spot in memory. So we have a do and a done, so this defines a block of code, and everything inside that do and done will be iterated through each time fruit changes until there's no more elements in the list. So we have apple to orange, and then it will be output, and in this case I've added a label, variable fruit equals, and then I have the $sign fruit. So here's how you embed the variable in a string, double quoted of course, to make sure the shell can expand this. Single quotes would not permit this to be expanded. Just a quick point there, and that's it. So what happens if we run it? Fruit loop. There we go. It iterates through each, and each time it runs the block of code and substitutes in the variable, the index variable fruit for the variable in the variable's value for the value that's output. If that makes any sense. Have a look at it. And one more thing, I wanted to highlight that there is a additional form of the if-then statements that allows you to evaluate the else branch So here I have a if-else statement, and you can take a look at the flowchart for it. If the statement is true, I have a block of commands that will exit, and if the statement is false, I can also provide a block of commands that will exit it. So that will execute in that case when the test is false. So here's an example of that. I have a test command is the first parameter equal to -v, so I can check to see if a parameter is present and do actual parameter processing in my script. So if it returns true, then it's going to execute a shift command, which we haven't talked about yet, but it is going to have the effect of moving all of the positional parameters over by 1, just copying the values, and the first one falls off. And then I'm going to run the exec command and take a look at whatever that parameter contains. So that's interesting. If, however, the v command wasn't there, it's just going to execute a cat, and that's what it's going to run instead. So you have if, you have then, and you have else, and the code blocks associated with each of those. It's just an extension of our normal if statement. Now you can get kind of carried away with this. This is what's called a nested else-if statement. There's a kind of a contraction here, so if I wanted to chain together if statements, it might end up looking something like this. So here is a rather snarly example that has two comparisons in it. So if a variable containing called word1 has a value that is the same as word2, if that is true, word1 and word2 are the same string, and word2 and word3 are the same string in these variables, that's a conjunctive that's going to say these two both have to be true. Then it's going to output, hey, all three of them match. That's the output here. Otherwise, I want to check to see, well, okay, they don't all three match, but does word1 match word2? If that's the case, then I'm going to report that. On the other hand, if word1 and word3 match, then I'm going to report that out. Otherwise, I'll compare 2 to 3, and if that matches, I will report that out. Otherwise, I will echo, nope, no match. I just did an exhaustive comparison and reported found no match of the three variables. So let's take a look at another form of the for loop. Instead of using an actual explicit list, let's see if I can get a little zoom in here. I'm looking at a file that's in your kit called argloop, and if you take a look at it, it's pretty much the exact same thing as previous, except for this basically has a built-in variable listing that is going to be returned when I use the @ parameter, and that is going to be an array type that has a list in it that will act in the exact same manner. So if I was to run this and pass it a list as a variable, so have a look at that. Basically, that variable expands into a list in the same way that the explicit list was set up. And take a look at argloop, take a look at fruit loop, and that'll give you the basics of the for loop. So now we're getting really fancy. If you take a look in your kit, there is argloop check args, and so now we have both selection and repetition at work in a script. So we can take a look at this. We have a test statement being evaluated, and what is it doing? The very first thing off the bat, it's checking to see if the positional parameter hashtag is equal to 0. Remember, we saw this. It's going to see, are there any arguments? And if there are, it's going to continue. If, however, there are none, that is, that number is 0, indicating 0 parameters were passed, I'm going to act like a command. I'm going to output the name of my script and a colon and a space and a brief message that says, I can't run, I can't go any further because you didn't enter a list of parameters. So I'm immediately going to call the exit keyword in my if statement, and that will exit the script entirely. Now, if this, however, returns false, this exit is never matched, and we move on down to what we saw before, that we now know that we have parameters, so that we feel safer that this is actually going to produce output. So the for loop will execute just as it did previously, and all of the arguments which were passed in the call to the script will be expanded and iterated through here. And one more thing I wanted to highlight, that there is a additional form of the if-then statements that allows you to evaluate the else branch. So here I have a if-else statement, and you can take a look at the flowchart for it. If the statement is true, I have a block of commands that will exit, and if the statement is false, I can also provide a block of commands that will exit it. So that will execute in that case when the test is false. So here's an example of that. I have a test command is the first parameter equal to -v, so I can check to see if a parameter is present and do actual parameter processing in my script. So if it returns true, then it's going to execute a shift command, which we haven't talked about yet, but it is going to have the effect of moving all of the positional parameters over by 1, just copying the values, and the first one falls off. And then I'm going to run the exec command and take a look at whatever that parameter contains. So that's interesting. If, however, the v command wasn't there, it's just going to execute a cat, and that's what it's going to run instead. So you have if, you have then, and you have else, and the code blocks associated with each of those. It's just an extension of our normal if statement. Now you can get kind of carried away with this. This is what's called a nested else-if statement. There's a kind of a contraction here, so if I wanted to chain together if statements, it might end up looking something like this. So here is a rather snarly example that has two comparisons in it. So if a variable containing called word1 has a value that is the same as word2, if that is true, word1 and word2 are the same string, and word2 and word3 are the same string in these variables, that's a conjunctive that's going to say these two both have to be true. Then it's going to output, hey, all three of them match. That's the output here. Otherwise, I want to check to see, well, okay, they don't all three match, but does word1 match word2? If that's the case, then I'm going to report that. On the other hand, if word1 and word3 match, then I'm going to report that out. Otherwise, I'll compare 2 to 3, and if that matches, I will report that out. Otherwise, I will echo, nope, no match. I just did an exhaustive comparison and reported found no match of the three variables. Well, that about wraps it up for the basics. This should get you on the path to scripting. If you are reading the chapter, you see why we have really kind of a parallel path between learning a little more advanced bash and shell and learning the fundamentals and starting to use the vocabulary of a script. So hopefully this was informative to you guys. I will see you on Wednesday night. We are going to probably be doing some interactive type work. So have your sleeves rolled up. Be ready to do some fun stuff. I'm gonna try to write some useful and interesting scripts, and I hope to make it worth your while. Or I have a boring thing we can do too. But just have fun with the scripts, and definitely arm yourself with the tools that I've outlined. Have a download of the PDF that's available on the D2L site, And the grading, I'm a little behind on awk. This one actually took a heck of a lot longer to do because I managed to drop a lot of the raw footage yesterday. So I had to redo a lot today, and here it is. So 6 o'clock, and I have not graded awk 1. So I will see you all Wednesday. Have a good week, and we're in the home stretch here. If you have any questions, as usual, give me a shout, and I will give you a shout back. Have a good week, and I'll talk to you all Wednesday.